Hello, everybody. Thank you for coming. Hi, welcome to the True Photorealism in Real-Time session. My name is Min Oh, and I'm with the Epic Games. Today, I would like to talk about how to achieve photorealism in Unreal Engine 4. So what's photorealism? It's a genre of art in which an artist studies a photograph, then attempt to try to reproduce the image as realistically as possible. So today we will discuss how we can achieve this true photorealism in Unreal Engine 4. So I would like to show a few of the key settings that can take your scene from the great to extraordinary. For this demo, we will focus on the car configurator we put together with McLaren and talk about the various requirement setting for the photorealism, which include high resolution reflection with cube map and using high precision vertex normal and high precision vertex basis for the your static mesh. So where you set that and what that means. And for the last thing, how to turn on clear code second normal and why that's cool. And when we are done, we'll take a look at the automotive material package. So first of all, I would like to jump onto our McLaren car configurator. So a bit of a background of this project is that this project was done as a partnership between Epic Games and McLaren. Together, we were able to overcome several challenges to real-time photorealism, adding more power to the Unreal's rendering engine and providing a boost to all those working in real-time product look development. So this is a look at our approach to the configurator. So we went to McLaren to acquire reference from a real-world car. So this includes all the material samples for the surface of the car taken from the photograph and then from the physical samples provided by a dealership. So we received access to the paint chip, as you can see on the left side of the screen. Also fabric samples, which is the right side of the screen here. And then finished the car paint on the surface of the sphere, which is the blue one here, which was perfect for the testing the surface material in the multiple lighting scenarios. Also the black sphere beside of the blue sphere here was used for the testing the character for the clear code. So on the top left side of the screen, so this is a setup of our reference shoot. So we used the 18% of the gray card and color checker, and this little board is a chrome board, and then here is a gray board. So it is very important to get accurately calibrated reference image that we can reproduce in the engine. So we are then able to recreate each material within UE4, allowing us to recreate the car entirely within the engine. So now let's take a look at the McLaren configurator. Let me play. So cars comes in. So the configurator is interactive, so I can change the color of the car. And I can open the door of the car. Let me put the behind the door. Turn on the headlight and then open the hood. So as you can see, outside of the car, we can see it's the primary outer surfaces, including various variety of the metal and carbon fiber and awesome looking metallic paint with a clear coat on top. So we'll take a look at how that was created shortly. Let me go inside of the car. Actually, let me close the hood and then go inside of the car. So inside, we can see the various surface type of the car's interior, including various plastic, fabric, and the synthetic material called Alcantara, which you can see on the dashboard right now. So many of these surface materials are available for free within our automotive material pack, which we will take a look at a bit later. Now let me go outside of the car and close the door. Go around, close the door. Here we go. Also, the special about this configurator also show off the exquisite engineering of the McLaren. So showcasing every single nut and bolt. The entire car is about 9 million polygons, all running in real time within Unreal Engine. So let me play the cinematic for you guys. I can still change the color of the car interactively. So in the beginning of the project, we ran into some technical challenges. So UE4 was already powerful enough to render CAD engineering data, but due to necessary simplification of the game engine, it proved difficult to get the sharp, crispy reflection that defines the line and the curve of the precision of the surface, such as an automobile. So digging into this problem, we were able to identify the key problem areas. The first was that when we imported the mesh into the UE4, the engine automatically optimized it for the efficient game use. This prompted us to add a setting to remove all those limitations and to let the engine to render full precision of the mesh information. But then that was only half of the problem. So the cube map, which was the basis for the reflected image, was also reduced in resolution as a game optimization. So this was also changed, allowing for the much higher resolution cube map and thereby allowing higher resolution reflection across the surface. So let me stop the cinematic here, and I prepared some image for you guys to show clear view of what I mean. So as you can see, before we having those kinds of settings, so you can see that reflection on the car is not clear enough. So after we have all the features, now we can have this beautiful, sharp, and crisp reflection on the car surface. So now let's have a look exactly where you make the change in the Unreal Engine. So start with high quality reflection. So as I described, this car has not a clear reflection over the surface of the car. So what you want to do is you want to go to the project setting and looking for the engine side. There's a rendering section. You click that and you go to under texture and use the reflection capture resolution. So this means that this reflection capture resolution is which adjusts the resolution of the HDRI cube maps that are used for the reflection capture actors. So this is set to default as a 128. Now let me just move this car a little bit that you can see the changing of the reflection. Now let's crank it up to the 1024. So we will go to the scene world outliner and look for the skylight. And you can see this cube map resolution is also set to 128. You want it to set to 1024 as well. So keep in mind that all this resolution must be power of 2. So this cube map setting defines the resolution of the image of each of the 6 sides of the cube map, essentially wrapping our scene in the 6K image. So as you can see, the reflection immediately gets much sharper. So of course, you might be asking, why not just leave this set to 1024 all the time? But the answer is that this great reflection comes at a performance trade-off, which means we are now using 384 times as much data for those cube maps. So that's a lot of work for your GPU memories and the processor. But now you get to have this great reflection on the car. Whether or not you choose to use this setting will dictate the class of the hardware your project requires. So now reflection looks great, but then the line across the surface of the hood is not sharp enough. So this is because of the mesh vertex normal encoding. Encoding in our scene are optimized for the game performance as well. So to fix this, we will tell Unreal Engine to use high precision normal encodings. So in order to do that, again, go to the edit and project setting. In the left section of the engine, you will find rendering again. And all the way in the bottom, you will see the optimization section, and then you will find the G buffer format. So it is set to default right now. So this means this is simplifies the data of the mesh normal to something more efficient. So, but still with enough data to look good on most of game models. But now let's set it to the high precision normals, which will encode normals 16-bit per channels now. So using this higher precision encoding will allow technique like screen space reflection to rely on the high precision normals. So, but as before, it comes at the cost of using more GPU memories. So there is one more step required to sharpen our reflection. Is that tell the mesh to use non-optimized set of normal and tangent. So you can think of normal and tangent as a set of vertex coordinate that defines the direction of the surfaces flowing. So when you use optimized normal and tangent, a very high density mesh may lead nearest vertex together, quantizing to the same vertex normal and tangent values, which means that this can lead to a blockage jump in normal orientation. So as before, these are simplified for the in-game efficiency. So, but we can optionally choose high precision encode normal and tangent as a 16-bit per channel vectors. So we will demonstrate this using this hood. So what you want to do is open up the static mesh editor. And in the static mesh editor, you will find the detail window. There's LOD0 section. You just go down, and then you will find the build setting. Extend that, and then on the bottom, you will see huge high precision tangent basis. You just check that off, and then apply change. So we now can see the reflection is much more clear and sharp. So keep in mind that your mesh must be tessellated enough to get this benefit to set this high precision normal setting, which defines the quality of the reflection. So static mesh that has less tessellation will have more stretching artifact in the reflection than static mesh that have more tessellation. So generally, you will need many more vertices than used for the typical game models. So again, all of this comes as a trade-off look versus performance. So next setting that I would like to show you is the dual normal. So one of the material we had a challenge with was carbon fiber. So as you can see in the image here, so carbon fiber is actually a fiber that is weaved together and then coated with a layer of the resin like a clear coat. So this means that when you look at the carbon fiber, you see the specularity of the two different surfaces simultaneously. So the surface on the clear coat on top, and then surface on the actual carbon fiber beneath it. Also, if you look at the image right here, in the bottom one is the actual photograph then taken carbon fiber. So as you can see, carbon fiber is getting, from the light, it's getting the cross shape of the specular heat. So this is because of the carbon fiber's directionality of the fiber underneath of it has a, cause of carbon fiber, that does react differently, depends on the lighting source and the angles. So it was very interesting and then cool looking material. So we wanted to have that look in the UE4. But before we have these features on the right top of the image, it doesn't show any cross lighting spec kit. So after we come up with this dual normal, we can have a same looking cross spec hit on the carbon fiber materials. So to simulate this two layer of the weaved carbon fiber and clear coat on top, we made this feature called dual normal with a clear coat. So to enable this dual normal, we wanted to go to the project setting again, and then a rendering section. On the material, you will find this clear coat enable second normal. You check that off. So engine will ask you, tell you to that this setting required to restarting the engine. So you can press the restart now, and then the engine will relaunch and recompile the shader, which will take some computing time, depends on your hardware spec. So for saving time, I prepared another engine that is set to use the dual normal. So I would like to apply this carbon fiber on my car's roof. So this project setting has a dual normal setting on. Once that setting is on, you want to make sure that you go to the material that you want to use the dual normal, and then make sure that you have this bottom layer normal that which this case you are defining the carbon fiber weaved texture on it. What you want to do is you plug clear coat normal custom output, plug that in, and hit apply. And just a little bit of compiling time. Now we can see that clear coat was dual normal. Carbon fiber is applied to the roof of the car. So for a clear view of what I'm talking about, I prepared another image that. So as you can see on the image, before we have only one layer of the normal, so we react with the lighting only gives only one specular. So after we have this dual normal, this more realistic look of the carbon fiber, you can clearly see the specular heat of the weaved carbon fiber underneath of it. So this advanced dual normal feature allows users to create complex material that we couldn't previously simulate. For example, there's car paint, so base paint layer, and then you can mix with the flakes, and then you can put clear coat on top of it. Or you can make this reflector pattern for your car reflector, and then you can have this plastic cover on top of it. So same as higher reflection capture resolution, so this dual normal setting also has an impact on the performance. So as always, you have to make a trade-off and use your priority to decide what your minimum hardware spec will be. So after we finish up the McLaren demo, Epic wanted to share as much of the content as we could. So we extracted almost all of the material and released those to the public as our automotive material pack, which is downloadable for free from Unreal Engine Marketplace right now. Let me open that automotive material pack here, and then show around what this pack has consists of. So start from bottom left. We have a car paint, which is a which is the material that using the dual normal. So as you can see, it is using the flake. You can totally see the flake, and then have a clear coat on top of it. This whole material comes with advanced option that you can customize your material, flake size and the color of it. But also it comes with various color that you can just download and drag and drop to your car or any of your static mesh that you wanted to use this material. In the back of the car paint, there's a carbon fiber, which we just talked about. In the right side, there's a tire material. And we also made Epic version of the tire details, so you can use freely. On the right side, there's a general rubber that you can use. In the back of the tire, there's a caliper material that you can use for your car's brake system. In the back of the caliper, there's a rim, which is various metal setting. Some of them are like more matte, and some of them are more glossy. Some of them are more metal, and some has like little more details in it. In the back, there's another metal, which is exhaust. And beside of that, there's a reflector material. Another example of the using of the dual normal material feature. In the back, there's a brake roller, which is for your car brake disc. This is a simulating carbon ceramic look of the brake disc. As you can see, you can clearly see the radial noise and the fractal noise in the back, and then anisotropic specular heat. And the right side, there's a relatively simpler version of the brake disc. Let me go back to the overview, and right bottom side, there's various metal that you can use. Some of them are dark, some of them are light, some of them are anodized, and some of them are dirt, and then some are like clear version that you can use. In the back of the metal, there's a leather, different color set, and just like other material, you can change your leather patterns. In the back of the leather, we also have a perforated version of the leather. Basically, it has this circular pattern on top of the leather. In the back, there's all-time my favorite material called Alcantara, which is a synthetic leather material. Also, Alcantara comes with various color. And right side, there's a glass material you can use for your windshield, car's windshield, and or any other glass material, the mesh that you wanted to use this glass material. For the last thing in the back, there's a plastic that is just a little bit different ones, matte version, a little bit more glossy version, and different color version. Also, the document link in that detailing explain the pack is available on bottom here with a question mark. Once you press that button, it will take you to the web page that explain about more detail about this automotive material pack. So today we talk about high resolution reflection and high precision vertex normal and tangent and dual normal. So with this feature, we can have a very sharp, crisp reflection in the scene and cool layered materials. So all these features and automotive material pack is available now in UE4. So please feel free to download and take advantage of it. Make your own car configurator and any of your own high fidelity scene for the Unreal Engine 4. So for the last thing, I would like to play Epic's Enterprise Showreel.